Today we're going to be working on the AP Calculus FRQ from 2013, question number 3. And in this particular problem, we are presented with a table of values for this particular case right here, which is hot water dripping through a coffee maker. So we know that the values on top will be the time in minutes of how much water is dripping from the coffee maker, and then the values at the bottom will be the amount of water dripping from the coffee maker. So the intervals given to us is from 0 to 6, and we're supposed to answer the first problem in this FRQ, and the problem on the first one is to use this data, which is in our table, to approximate the value of C prime of 3.5, and we need to show the computation that would lead to our approximation based on the table of values. So since we're looking for C prime of 3.5, we're basically finding the derivative of the function, which is in this case given by the table. So we are looking for C prime of 3.5, and we know that to find a derivative of a function, we can use the formula f of b minus f of a all over b minus a. And in this case, since we're looking for f prime or c prime of 3.5, and 3.5 is in between the values of 3 and 4, so to find the derivative of c or the derivative of 3.5 based on this table, we simply need to find f of 4 minus f of 3 all over 4 minus 3. So in this case, we know that f of 4 is equal to 12.8, and we know that f of 3 is equal to 11.2. So using the formula to find c prime of 35, we'll simply use this, so we plug it in. So f of b or f of 4 is going to be 12.8 minus f of 3 of 11.2. If we subtract 12.8 and 11.2, it will give us a value of 1.6. So therefore, we'll have 1.6 all over 4 minus 3, which is equal to 1. So it's equal to 1.6. So therefore, if we're going to find the derivative of c prime of 3.5, it is simply equal to 1.6. And since this is a derivative, so this is a rate of change, so our unit of measurement will be ounces per minute. So this is how we answer problem letter A on this FRQ. Now for problem number 2, we need to find, or is there a time t between 2 and 4 where c prime of t is equal to 2. So in this particular case, we're going to check if we're going to find the derivative of c prime of t between 2 and 4, and it's going to equal to 2 using the mean value theorem. So since this particular formula is associated with the mean value theorem, so if in the interval 2 and 4 we're looking for c prime of t, which is equal to 2. To justify this, we're going to have f of b, which is equal to 4, and f of a, which is equal to 2. So if we're going to use c prime of t in this problem, using this function, we'll have f of 4 minus f of 2 all over 4 minus 2. And f of 4, using our values, is 12.8 minus f of 2, which is 8.8, all over 4 minus 2, which is equal to 2. And we know that 12.8 minus 8.8 is equal, or will give us 4 all over 2, and 4 divided by 2 is going to equal to 2. So since we found out that c prime of t is equal to 2 in the interval between 2 and 4, we can say that with the mean value theorem, there is at least one time given by t where it's equal to 2. So that's how we will answer problem number or letter B in this equation. Now for the next one, we're going to be using the approximation using Riemann sums, using the midpoint formula, and we're going to approximate the value of 1 over 6 integral from 0 to 6 of the function c of t dt. So here we are supposed to use the midpoint formula, and there should be 3 sub-interval, so we'll be using M3 of equal length using this data set. So if we have this function to find the midpoint formula, we know that we can have the first triangle from 0 to 2, and then from 2 to 4, and then from 4 going through 6. So now that we have our interval, which is 0, 2, 2, 4, and 4, 6, the midpoint method would be using the middle value of your interval between 0 and 2, which is 1. So we're going to be using c of t of t equals 1, which is 5.3, and so on. So to find the sub-intervals, we simply use 1 over 6 multiplied by the integral of this function using the Riemann sums, which is going to be the width, which is 0 to 2 is 2, multiplied by f of 1, and add it to the interval from 2 to 4, which is also 2, and this time we will be using the midpoint, which is f of 3, plus between 4 and 6, it's also 2 units, and we will be using f of 5 because that is the midpoint of that rectangle. So by substituting it, we'll have 2 times f of 1, which is 5.3, plus 2 times f of 3, which is 11.2, plus f of 5, which is 13.8. So we have 1 over 6, and we're going to be multiplying each one of them. So 2 times 5.3 is going to give us and since we have 2 times 5.3 and 2 times 11.2 and 2 times 13.8, they have a common factor of 2, so we can make this a lot quicker if we're going to factor out the 2 and simply add 5.3 and 11.2 and 13.8, because this problem is in the non-calculator part of the test. So without using the calculator, it will be a lot easier if we partitioned our function similar to this one. So we have 1 over 6 times 2 multiplied by the sum of this function over here is going to be 30.3, and if we multiply 30.3 times 2, it will equal to 60.6, and 60.6 is approximately equal to 10.1 ounces. So this is how we use the midpoint formula to approximate the value of 1 over 6 multiplied by the integral of ct dt from 0 to 6 using 3 sub-intervals. And for letter D, we're supposed to find the amount of coffee, or coffee in the cup, needed or modeled by B of t. Using this model, we need to find the rate at which the amount of coffee in the cup is changing when t is equal to 5. So the keyword here that we're going to be using is rate at which the amount of coffee in the cup is changing. So this particular statement here, it means that we're looking for the derivative of the modeled function, which is b of t. So if we are given b of t, which is equal to 16 minus 16 e to the negative 0.4 t. To find the derivative of this, b prime of t is simply derivative of 16 is 0 minus 16 multiplied by our, or using the power rule, it's going to be negative 0.4 and multiplied by e raised to the negative 0.4 t. So this is our function. So b prime of, we're looking for b prime of 5. So by substituting negative 16 and negative 0.4 times e to the negative 0.4 multiplied by 5, and we are now basically substituting everything so we can simplify this. And if we multiply negative 16 and negative 0.4, it will give us a positive value, so this will equal to 6.4 multiplied by e to the negative 0.4 times 5. And since we have a negative exponent here and we don't need to evaluate the value of e, we can simplify this by changing it into a positive exponent. So we'll have 6.4 all over e to the positive 0.4 times 5. And if you want to further simplify it, 0.4 times 5 is equal to 2, so we'll have 6.4 all over e times 2. And since this is the rate of change, we need our unit of measurement by ounces per minute. And this is how we answer the 2013 question number 3 for this particular FRQ in AP Calculus.